Hey there, my name is Matt Williams, and I'm one of the evangelists here at Datadog. Recently, I did a session at the AWS Summit in New York City about monitoring Lambda. Now, the session was not recorded, so I've decided to record it now that I'm back in the office. And the session was called Monitoring Hold the Infrastructure, Getting the Most Out of AWS Lambda. Again, my name is Matt Williams, an evangelist at Datadog. And if you have any questions, you can reach out to me at matt.williams@datadoghq.com, or I'm on Twitter, where I'm Techno-Evangelist. So this session was about 45 minutes to 50 minutes. We had a lot of good questions at the end. Obviously, we won't have questions at the end of this session, but you will get to hear the session. So let's go for it. So the plan for the session is basically 5 sections. There's a little bit of a Datadog overview. Now, I wanted to keep this as minimal as possible. This was not a Datadog session, but rather, how do you monitor Lambda? And I wanted to keep it kind of platform agnostic. Then, I talked about the why and what of Lambda. What is it? Why do you care about it? What's so cool about it? Because I do think it is a super cool platform, and it's going to change things immensely. Then, how do you add Lambda to your infrastructure? What's the process of getting started with Lambda? The 4th section is Monitoring 101. Now, this is a short version of a session that we do on its own many times. Monitoring 101 is super important. And the idea is to show you the key metrics that matter. And it's impossible to tell you what the key metrics are for your environment. You have to decide that for yourself. But this gives you at least a framework you can start from. Then the final section is adding AWS Lambda to your monitoring. So now that you know about how to get started with Lambda and how to monitor, how do you monitor Lambda? Because Lambda introduces some interesting hurdles that you need to get over in order to add it to your monitoring platform. Okay, so first thing is going to be Datadog Overview. Now, in case you're not familiar with us, we're a SaaS-based infrastructure monitoring platform. The idea is you load up an agent on each host that you want to monitor, and we don't really care if that host is up in the cloud. Maybe it's a virtual machine or EC2 instance. It could be an instance on Azure or on Google's platforms. It could be a container like Docker somewhere on a VM or a physical box. It could be microservices. It could be all sorts of different things. We don't really mind where it is as long as you can load up this Python-based agent, which is where the problem comes in for Lambda, because you don't really have the opportunity to run a Python-based agent with Lambda. We focus on the modern infrastructure. We process a huge amount of data every single day. We're dealing with about 1 trillion metrics every day that we bring in from all of our customers. So we know a thing or two about collecting a huge number of metrics and then figuring out what's most important. And once the customer has all these metrics, we give them really great dashboards. We provide intelligent alerting so that they can get on with their jobs, but be alerted to problems and be able to deal with them quickly. We're of the mindset that you should be monitoring everything. Monitor everything no matter what it is. It could be the operating system. It could be databases, chat platforms. It could be configuration management tools, web servers. It doesn't really matter what it is. We want to collect everything there is to know about those platforms. Now, our agent is going to be collecting every 15 seconds or so, but you can be pushing data to us as often as every second. And we're going to keep it at that 1 second granularity for 13 months or more if you'd like. Okay, so the what and the why of AWS Lambda. In case you're not familiar with Lambda, it's really the next stage in a long progression of virtualization. In the early days, we had just physical boxes. You called up Dell, or you called up Gateway, or you call up Northgate, or you called up all these other companies, HP, and you bought a physical box. You install that physical box, you take care of that physical box, you install bits of software on there, and then to take more advantage of the machine, along came virtual machines on those physical boxes. And from there, AWS started selling those virtual machines and called them AWS Instances or EC2 instances. But to take better advantage of those instances or virtual machines, along came this technology referred to as containers, whether it's Docker or Linux containers, lots of different ideas around that. And then the most recent in this progression is Lambda. So let's take a look a little bit at each one of these different ideas. So a physical box, you buy a physical box, it's a predefined resource, predefined capacity. It's variable consumption, but you're paying for the entire box. So, you might buy an entire box, but only use 10%, or you might use 90%. It depends on the load, what you're trying to do on that box. Ideally, you don't want to run too many applications because then your security footprint gets bigger and bigger and it's harder to deal with. So you want to run the minimal amount of software on there, but that means you might only be using a small percentage of that box and you're still paying for all of it. You're paying for the box, you're paying for the power and cooling and maintenance as well. And if you want to scale that up, well, you just give a call to Dell and order another box. So scalability just requires getting new hardware, and that's going to take a little while. And maybe, depending on the company, maybe some extra bureaucracy as well. So then along comes virtual machines on those physical boxes. And this allows you to keep that security footprint low per machine, but you're loading up multiple virtual machines on every physical box. You've got similar physical resources, capacity, and scalability, but you've got a lot more flexible virtual machine resources and capacity. But you're still paying for 100% of that box, 100% of the cooling, the power, and so forth, regardless of how many VMs you load up on that physical machine. You do have variable consumption on each VM, but there's an overhead for each virtual machine. Every VM requires a little bit extra percent, a few percent of that overall CPU just to deal with creating the virtualized hardware. So it's a good next step, but it's not perfect. Amazon comes along and starts to basically rent out those virtual machines. They call them EC2 instances. And instances are scalabilities at the VM level, abstraction at the hardware level, and there's no real physical restrictions, but you're paying for 100% of that instance. So a lot of the same issues that you had with a physical box now apply to this virtual machine. Granted, the virtual machine is a lot less expensive to maintain, but you've still got to pay, you're paying for the entire virtual machine or instance. And again, you have variable consumption. You might be using 10% of the box or 100% of the box, and you're paying the same thing. But it's much easier to scale each VM. Basically go into a console or use the API, and within one button press or one line in your script file, you've got one more instance or 1,000 more instances. So really easy to scale. So along comes containers. And there's been containers for a long time in the form of Linux containers, but what really made this popular was Docker. And Docker has been around for 3 years, maybe 4 years, and it's a lot more flexible. You have variable consumption, and there's no virtual machine overhead. Scalability is at the application level, which is pretty cool, and abstraction at the operating system level. But you're still paying for the entire instance that container is running on, because often a container or a set of containers are running within a virtual machine. They could also be running on a physical box, but whether it's on a virtual machine or a physical box, you're paying for the 100% of that place, of that host. So it's nice that you're able to consume more of that physical box or more of that instance, but you're paying for 100% of it regardless. So the next stage is Lambda. Lambda is pretty amazing. It's a lot more flexible and variable consumption. You're paying basically on the amount of time and memory used by your Lambda function. Scalability is at the function level, abstraction at the runtime level. Now, it's very early days, but what's probably one of the coolest things about this is that you are paying such a minimal amount for access to this functionality. You could have potentially a cron job that runs for a half second at a time, and you want it to run every 5 seconds for an entire month. That counts in their free plan. It's really amazing. So maybe that's one less EC2 instance that you need to buy because all your cron jobs and other types of jobs are running as Lambdas. There are entire companies that are switching to Lambda as well. I've seen iRobot get on stage at the AWS Summit Santa Clara talking about how they've transitioned all or most of their infrastructure from physical boxes and EC2 instances all to Lambda. Pretty amazing stuff. So let's get a few Lambda concepts out of the way. Now, the first off is you might be wondering where I'm going with a Roy Rogers picture, but basically all Lambdas are trigger-based. They're triggered by something that happens. So the something that happens is always going to be an AWS service. Maybe it's an S3, a file shows up in S3, or it gets deleted. Or it could be something comes in from a stream from Kinesis, or DynamoDB, or the API gateway. Whatever it is, that's what triggers the Lambda to start running. And if there's just a single file that's added to S3, you get one Lambda. If there's 10,000 files that get added to S3, now you've got 10,000 Lambdas that get triggered. The next concept is that it's stateless. What this means is that each Lambda doesn't know about your overall application. You have to feed it the information, and it processes it, and then gives you a result. And it doesn't know anything about any state of the overall application. And it doesn't save any state on its own. It's up to you to push that data somewhere. You might push it to S3. You might push it to another Lambda, trigger another Lambda based on the results of your first Lambda. But that's an important concept. That it's trigger-based and it's stateless. Another important concept is, it's infrastructureless or serverless. You don't have to think about a container or an instance on AWS. All you have to care about is your function. So it is serverless, at least as far as you're concerned. There is a server back there. There is a container for every one of your functions, but you don't have to think about that. So what is a AWS Lambda function? Well, every function is actually a bit of executable code that you've provided that's running on Linux containers, that's running on an Amazon Linux box. Now, you don't know how that Linux box is running. You don't know if it's an EC2 instance or a physical box. All you know, you don't even know what the container really looks like. All that container implementation is hidden from the user. All that you do know is that you have access to a temp directory. You have a built-in runtime for Java and for Node and for Python. And there's some basic libraries installed, like ImageMagick is installed on the box. But that's all you know. Now, other languages are supported through, doing an exec or spawn through Node or Python. Now, price is based solely on execution time, quantity, number of Lambdas that are running, and memory that's consumed by each Lambda. And really, memory is the only configuration option that you have for setting up Lambdas. You set up the amount of memory it's going to use, and that determines the processor used and other types of things. But really, all you have control of is memory. So what can trigger an AWS Lambda? Well, the first thing is files. So when you add or delete a file from S3, that can trigger a Lambda. You could do database updates from DynamoDB or streams from Kinesis or messages from SNS or SES. When a user logs in or does something with their user data through Cognito, that can trigger a Lambda. Infrastructure changes through CloudFormation or even through CloudWatch. When you add a new EC2 instance, that's going to trigger a CloudWatch log. And that log line can trigger a Lambda to say, hey, there's a new EC2 instance. It's got this tag associated with it. Let's go ahead and add it to the maybe an ECS cluster and add some other prerequisite services onto there and get that running in ECS. You could also rely on Internet of Things type stuff, like an Echo. There's the Amazon Echo and Alexa that can trigger a Lambda. In fact, you could create a skill on the Echo that says, ask it a question, and every time you ask a question, it launches up a Lambda, and that Lambda is what responds to the question. Concurrency is another important thing to think about. Every event that happens on one of these trigger sources will trigger a new Lambda function. So if I've got a single file on S3 or I've got 100 files on S3, each one of those is going to trigger a new Lambda function. Now, right off the bat, there is a safety limit of 100 per region. So 100 in US East 1, US West, the different Europe regions. And there's about 7 regions that Lambdas are supported in. Now, if you want to up that safety limit, that's not a problem. Just contact support. They'll be happy to change it. So what are some good use cases? Well, one of the first things is bootstrapping a startup. You know that the first million requests per month are free. Now, it's not just the first million requests, period, but first million requests every single month are free. And up to 3.2 million free seconds per month. Now, it's actually 3.2 free, what they call memory seconds. So you take the overall number of seconds, divide it by the amount of memory that you're choosing to use, and that's the number of seconds that you're allowed to use. So if you choose to have 128 megs of RAM, then you're going to get more time than if you up it to the maximum of, I think, 1.5 gig of memory. Another great use case is cron. Doing a cron job, you need to run this thing every 10 seconds or every 30 seconds or every 2 seconds. This is a great use of a Lambda. Because maybe it's something simple that needs to run several times a day or several times an hour, and just set up a bunch of Lambdas to do it. And that way you don't need to have a dedicated EC2 instance, and you're probably going to save a lot of money. Maybe there's file manipulation. Every time you upload a new file to your S3 account, which is going to be served using a static website that also might be hosted on S3 or it might be hosted on GitHub or wherever it is. Every time you upload that file, you want something to happen. In fact, this was the original idea for Lambda. Basically, customers came to Amazon and said, hey, S3 is awesome, but we want S3 to be able to do stuff. When I upload a file, I want to have a watermark automatically added to that file. When I upload a video file, I want it transcoded to multiple different qualities. And so that was the original idea for Lambda. They thought about how could they do this and got bigger. The idea got bigger and bigger and bigger and turned into Lambda. You could do API translation. If you're translating from one API format to another, this is a nice kind of gateway to support both sides. Stream processing. You want to do sentiment analysis on social media streams, or as you're scaling infrastructure. Also providing mobile or Internet of Things backends. If you've built an amazing mobile app and you're not sure if 2 people care about it or 2 million people care about it, maybe you set up your back end using Lambda, and it doesn't matter if 1 person responds per day or, again, 2 million, 10 million, whatever it is, you'll be able to scale up really, really quickly to no matter what the demand is, and you don't have to think about it. It's really pretty amazing stuff. Now, I've got 2 other great examples of Lambdas that I've just found in the last few days. The first is Goad, which is a load tester. Basically, you can run this command, this Go-based command on your local machine, and depending on the configuration options, is going to launch Lambdas in different regions and start pounding on your server. And now it spits out the response to SQS, and the Goad command will read SQS to read the results. It looks like a super cool application, and I look forward to playing with it soon. Another neat one that I found was Benchling. Basically, Benchling is doing genome searching, and they do a few 100,000 searches every month, looking through about 90 gigabytes of data. And they've transitioned from this old infrastructure using physical boxes and EC2 instances to a new infrastructure that uses Lambda. That Lambda infrastructure, has saved them a huge amount of money. Their old infrastructure cost them multiple $1,000s per month. And the new infrastructure scales far better than the old one ever could. And it costs about $60 per month. So it's an enormous change, enormous ability for them to do more and pay a lot less. They've written up their experience up on their weblog, so definitely check that out to learn more about some cool uses of Lambda. Now, Amazon has some best practices for working with Lambda, and you can take a look at the URL at the bottom of this slide that points you to that best practices document. Basically, write stateless style code, make sure there's no affinity between the code and the underlying compute infrastructure. Should avoid declaring variables outside of the scope handler because you have no guarantee whether those variables are going to be available to the next run. Okay, so that's a little bit about why and what Lambda is. Now let's talk about adding Lambda to your infrastructure. What's involved in getting started with Lambda? Well, the basic steps to working with Lambda are, well, 3 steps. Write the code, set up AWS Lambda, and then do a debug. Yeah, how easy is that? That's pretty easy, 3 steps. Well, there's a little bit more involved because writing the code, it's going to require a bit of work to get the code just right. You can write the code using Node or Java or Python or anything you want using an exec or spawn. And then setting up AWS, that's actually the really easy part. There's a web interface for doing it. Super easy to do. It will get a little annoying after the first time. Yeah, maybe 1 or 2 Lambdas you set up, but then you're going to want to find another way to do this. And then debugging, you're not going to have the fancy debuggers that you're used to. It's all debugging via logs, via print statements. So go back to the way you learned Pascal in 5th grade, and that's the way you're going to be doing debug here in Lambda, at least for now. Maybe soon maybe at some time in the future that'll change. But right now, debug is via logs and print statements. Okay, so let's get into a little bit of a demo of how Lambda actually works. So first thing you do is go into the console and click on Create a Lambda function. And what that's going to do is select a blueprint. You can choose what blueprint you want to use as the starting point for your Lambda. Now, each blueprint is basically some code that will do some simple function. On this screen, you can see there's Splunk logging, there's Sumo Logic logging or log processing, there's Alexa Smart Home Skill Adapter. And if you look through these, there's about 50 of these blueprints so far. You'll also find a Datadog blueprint for making it easier to monitor RDS instances. And there's a lot of other vendors that are in here as well. We can just skip that and start with nothing, start with a blank canvas, which is what I've chosen. The next step is to configure a trigger. So here's where we can set up most of the triggers. You can see API Gateway, Internet of Things, CloudWatch logs, Cognito, and so forth. But I'm going to choose S3. And I've already chosen the right bucket, evangelism. And now I can say, well, when do I care about, when do I want S3 to trigger my Lambda? Do I want to trigger for everything, or only when something's removed or when something's created? And specifically when it's created, do I want to do it on a put or a post or a copy? And then I can specify the prefix, kind of the directory where all my images are going to live. So look in this image directory, look for everything with a PNG extension, and then trigger a Lambda based on those events. So click on Next, and now I can specify a function name. So I'll just give it something silly like myCoolLambda, and I can choose a runtime. So the runtime is going to be Java 8, Node.js, Node.js 4.3, which introduces promises and a few other things, and then Python 2.7. So I'm going to leave it at Node 4.3, and you can enter in your code, and then enter a handler name and a role. So you can choose an existing role, or create a new role. I've added an existing role that I created earlier. And then specify the memory. So the default is 128 megs, but you can go up to, I think, about a 1.5 gigabytes. And that's pretty much it. Click on Next, and finally create function, and it will create your Lambda function. And now it's pretty much ready to go. So that was pretty cool. But you can see how, the first time it's awesome. It guides you through the process. The second time gets a little bit cumbersome. You start, especially when editing the triggers, it's easy to miss a step and there's no way to kind of go back. So you have to start over. So it gets a little bit annoying. And so it makes sense to look for another approach. Now, there are many approaches. There's Lambda or node-lambda. There's Apex. There's serverless. There's a new thing coming from Amazon called Flourish, I believe, which will be really amazing. But let's take a look at using node-lambda. I really like the idea of node-lambda. Node-lambda is also not really set up for doing huge numbers of lambdas talking together, but really just for setting up individual lambdas. But what it does do is pretty amazing. So there's a bunch of commands you can use, install node-lambda, and then npm run setup, npm run dry run, npm run deploy. So let's take a look at those. First off, to set up node-lambda, specify a package JSON. This really is done for you for the most part, but you can change some of the scripts that are run. Specify an .env file This is where you're going to put in your role ARN, specify which region you want to run these Lambdas in, what your handler is going to be, memory size, timeout. In this case, I've set a timeout of 30 seconds, what my runtime is going to be, and so forth. And in this case, I'm actually pulling the session token and the API key from my host's environment variables. And then an event JSON file. The event JSON is, if you do a dry run, it's basically going to run it locally rather than running it up on Lambda. And in order to do that, you need to have an event that triggers your Lambda. And so that's what this is. This is the local version of an event that's going to trigger the Lambda. And then you have your code. In this case, I've got a pretty simple, relatively simple JavaScript file for using Node.js. And in my Node.js file, I've got basically 4 functions that are running. First thing it does is download the image. So the idea is that I load up some images to S3 and I resize them and change them to a JPEG and upload them back up to S3. So the first thing it needs to do is download those files from S3 to that local temp directory. So that's what download does. And then the output of download is handed off to convert, and convert is going to convert that to a JPEG file with certain options set. And then it's going to click on to processing. Processing is going to resize each image to, there's 4 different sizes. There's a thumbnail, there's a small, medium, and large. So it's going to do that resizing. And then the fourth and final thing is upload it. Upload it back to up to S3. So if I do an npm run dry run, what happens is it just runs it locally and verifies that it's all working. And if you had any problems, you'd see it here. You'd see which line there was a problem at. You get all the benefits of running it locally. You get a little bit more debugging capability, which is really pretty cool, especially if you're new to Lambda. So the next step is npm run deploy. This is going to push it up to AWS and get it ready to run in production. So it looks like it's done. And when it's done, you're going to be brought back up to the dashboard. You can go back up to the dashboard and see invocations. You can see duration. You can see any errors that happen, as well as how many times it got throttled for going over that 100 limit initially. You can also go to the logs. The logs are where you're going to spend most of your time debugging a real production Lambda. So there's a log stream for each time you deploy a new Lambda, it shows up as a new log, and then you get a new log every few hours as well. So if you click on one of those logs, you'll see the output of the log, and you'll see actually the first statement of my application is actually spitting out the event. And that's pretty much all there is to my little app. And let's try it out. So here I'm adding one file to a S3 bucket. I'll refresh the other side, the output, and I can see that there are 4 directories that were created: a thumbnail, small, medium, and large. And I can click on each of those files that got created, and you see the different sizes. Cool. So if I add another image, I get another 4 files that get output. So we should see those show up pretty quickly. I believe we can see the output. So thumbnail, small, medium, and large. Cool. So now what happens if I add a lot of files? So in this case, I'm going to add about 130 files, 140 files. So we should see those show up in just a second. There we go. Dropping them on here. And really here, the bottleneck is how quickly can I upload these images up to S3. But pretty quickly, we're seeing the output show up. And I'm just kind of refreshing the right side of my forklift application. And I can see these images showing up right now. There's 87 uploaded and 165, 180, 190 images that are being spat out into the output directory. And we could go through and take a look at each one of these. And I could sit here and watch the numbers climb. But I think you get the idea. It's basically creating multiple Lambdas, and we have a lot of Lambdas all running at the same time to process all this load. So that's pretty cool. Now, I do want to mention there's a few other tools out there. There's Apex. You can reach at apex.run. There's the serverless framework at serverless.com. There's also Chalice. Chalice is pretty cool. It takes a slightly different approach. It is, if you were to create any applications, any web applications using Flask, you could just do a search and replace of the import of Flask to Chalice, and you've got a working application that works with Lambda and API Gateway. So build out your application, test it with Flask, make sure it's all running, and then change it to Chalice, press deploy, and it will automatically create the API Gateway as well as the Lambdas to respond to those API Gateway requests. And you'll have something up and running. I mean, you could be up and running within 20, 30 seconds with Chalice. It is really pretty amazingly cool. So that's a little bit about adding Lambda to your infrastructure, how to get started with Lambda. Now let's talk about monitoring 101. And this is going to be the super short version. We do this as a longer 30-minute to 45-minute session as well, but this is just the quick 5 to 10-minute version. So the first thing I'd like to show is, you're driving in a rainstorm. And the only way you're able to drive successfully is if you're paying attention to all the metrics that are going on. Well, not all the metrics, but a lot of the metrics, the most important metrics that are going on with your car. You're paying attention to the speedometer. You can see how fast you're going. You're paying attention to how fast the rain is falling and how much water is hitting the road. And you're using that information in conjunction with the speed, to adjust your speed to make sure you're driving safely. You know how recently it started raining, so how slick the road probably is. You know about your tire pressure, so you know, maybe you should be slowing down because your tires are nearly flat. You know about whether your car is overheating. You know about the lines on the road. You're paying attention to all these metrics. Now, you're not paying attention to everything. The car is collecting a lot more information about when you press the brake and when you accelerate. Because if you don't do this stuff, you're going to end up hitting something. To avoid that, you just pay attention to all these different metrics that are being collected. Again, the lines on the road, the speed, and so much more. You might not even know that you're paying attention to this stuff. So collecting data is cheap. You should be collecting as much as you can. You're only going to be focusing on a small part of it, but you should collect all the time. And when there's a problem later on, your mechanic can take a look at onboard computer of that car to understand what was the real problem and be able to troubleshoot very, very quickly. Collecting data is cheap. Not having it when you need it can be expensive. Not having it for that mechanic is going to be really expensive because now he has to drive around the block a few times, try to figure out what just happened. Maybe he's not going to be able to figure out and say, hey, here's your car back. There's nothing wrong, when you know there is something wrong. So when it comes to your infrastructure and monitoring your infrastructure, well, there's a lot of metrics that you might be collecting. If you're collecting everything, you could be collecting 1,000, 10,000, maybe more every single second. So that's a huge amount of data that you need to process, that you need to pay attention to. Or is it? Do you have to pay attention to everything? Well, one of the common questions is, well, which metrics do I need to focus on? Which metrics do I need to pay attention to? What are the most important metrics? And there's no way for me to answer that question. There's no way for me to know what is the most important metric in your environment, because I don't know your business goals. I don't know your infrastructure. I don't know all the different pieces that are involved. I don't know how the people in your organization are organized. I don't know any of that stuff. So there's no way for me to tell you what are the 5 or 10 key metrics. All those things need to take part in understanding what are the key metrics. What I can give you, though, is a framework for understanding all the metrics that are being collected. Over the last few months, we've been creating blog posts on Monitoring 101. And initially, it was a 4-post series that just talked about how do you think about metrics in general? What are the most important metrics? Is there a way of thinking about metrics? And we've moved along as time has gone on, looking at different products that we monitor. And we produce 3 or 4 blog posts on each one. And usually 2 or 3 of them are always going to be platform agnostic. We don't care what platform you're using, whether it's Datadog or one of our competitors. they apply just the same. But there's always at least one article that does talk about, okay, like we've talked about it in general, now here's how to apply it to Datadog. So Monitoring 101 is a great series of posts. And if you think you don't need to read it all, because there's a lot of text there, but you want to just get a quick overview, that's what I'm here to do right now. So basically it comes down to three buckets of metrics. There are work metrics, there are resource metrics, and there are events. The work metrics are the most important thing. The work metrics include throughput, success, error, and performance. So throughput could be number of requests processed per second for your Nginx server, number of web pages requested. And success could be the number of 200s, and error could be the number of 404s that result from all those requests. And usually when you're looking at success and error, it's not so good to look at the scalar values. There were 200 requests, but to know that 90% of them were successful, or 10% of them were failures or errors or 404s, that's a really interesting number. Resource metrics on their own are kind of useless. So there's utilization, saturation, error, and availability. Utilization could include CPU utilization. And on its own, CPU utilization is kind of useless. It doesn't really tell you much. 10% or 90% CPU utilization doesn't tell you a story. All it tells you is how much of your processor is being used. But you add that in context with throughput, that becomes a lot more interesting. 10% CPU utilization, and it's processing 90,000 requests per second, and all of a sudden it goes up to 98% utilization, and you've dropped down to 2 requests per second. Well, that's a really interesting story, and that's something you can work with and try to solve a problem. Saturation is another great example of a resource metric, and basically you can measure that as queue length. If you start building up a queue of things that need to get processed, it's because your resource is oversaturated. Now, the third bucket is events. That could include code changes, alerts, scaling events, and so forth. So a code change could be, GitHub. There's a new commit to GitHub, or Jenkins just did a deploy. On its own, hey, there's a new deploy, there's a new deploy, there's a new deploy. Doesn't really tell you much. It just says, hey, some developer's been very active in getting stuff out. But if there's a new deploy and utilization goes from 2% to 90%, and throughput goes from 90 million requests per second down to 2, well, that tells you a much fuller story, which may be a result of that code change. Now, that's 3 different buckets. What do you focus on? Well, we think you should focus on those work metrics. Those are the most important things. You should page or alert on those work metrics. Everything else just helps you tell the story, helps you understand what's going on. So you should investigate using everything else. You should investigate using the other work metrics and the resource metrics and the events. Use all those things to figure out what just happened. Now, this is not a single level of stuff. You need to keep digging deeper until you fully understand what's going on. So if you have a problem with your Nginx server, you look at the work metrics, then the resource metrics and events, and you start digging deeper, maybe looking at the SQL Server or MySQL box that's helping to support that Nginx server. And you look at the work metrics and resource and events, and you look a little bit deeper, maybe at the file system or at the EC2 instance, and to try to look at those work metrics and resources and events. And all of these things will come together to help produce a full story as to what's going on, so you know exactly where to spend your time troubleshooting. So that's a little bit about Monitoring 101. So now let's talk about adding AWS Lambda to your monitoring. Right off the bat, you get a bunch of Lambda metrics, and they're part of CloudWatch. CloudWatch is watching how Lambda is doing, and it's recording the duration of each Lambda, and the minimum, the maximum, the sum, how much total time is being consumed by each Lambda function. It's also looking at the number of errors, the number of invocations, and the number of times it was throttled. How many times did we hit that 100 limit? The problem there is that we're just looking at the overall Lambda. We have no idea what's going on inside the Lambda. What's your function actually doing? And so there are 3 options for monitoring your Lambda function. The first thing we would do is add a custom metric to CloudWatch. You could also add a metric directly to the monitoring application. Your application or your function would push a value directly to the monitoring application. You could also add a line to the CloudWatch logs. So each of these is, there's some strengths and weaknesses to each of these. So let's take a look at those in more detail. First off, CloudWatch metrics. Basically, you can create as many CloudWatch metrics as you like. You can only update them once every minute. Well, you can actually update them more often than that. But if you send, say, 10,000 values to a CloudWatch metric within a 1 minute period of time, what CloudWatch is going to do is create a histogram. It's going to create the average, figure out what the minimum, what the maximum, what the sum is, and that's what gets recorded. You're not going to collect all 10,000, just going to collect that histogram. You could also send that value directly to the monitoring app. Now, the downside to this is it adds complexity and size to your Lambda, which ideally should be kept as small as possible. Also, if you're creating 10,000 Lambdas and you're sending values to your monitoring app maybe 10,000 times a second, can your monitoring app handle that amount of traffic from that one source? I don't know, maybe. Now, the benefit is there's no lag time. With CloudWatch metrics, you're looking at least a lag of a minute, maybe more. With logging, you're also looking at a little bit of a lag time. We have about a 2-minute lag there, but we're going to collect all the metrics. So if you send 10,000 lines to the log, we're going to collect all 10,000 of those values. How do we do it? We basically tell you to add a line to the CloudWatch logs. And that line is always going to have the format of monitoring, all in caps, followed by a pipe, and then the Unix epoch timestamp. That's the number of seconds since, I believe, January 1st, 1990. And then pipe, and then what the value is. What value do you want to assign to your metric? What's the type? And the metric type can be a count or a gauge. The metric name, so it's probably going to be something.something.something, or maybe a few more dots and a few more somethings. And then finally, pipe and tag. What tags do you want to assign to this metric? In Python, you can do this very easily using print, and Node.js do a console.log. So here's an example from my download function. Basically, at the beginning, I'm doing HR time to record the start time. Then I do my get object. And then I do a process HR time to record the total amount spent doing that download. And I'm recording two different types of metrics. The first off is a count. And the count is the number of times that something got downloaded. And I'm just pushing the value 1 to that count metric. And I'm assigning it some tags. Basically, one of the tags is demo mat. Everything I do, I assign a tag of demo mat. That way I can see all of my metrics all in one place. And then I also assigned it a tag of image function download. And so in the other functions, I have image function process and image function convert. And that way I can create on one chart a stacked bar chart that shows, my download took this much time, and my processing took that much time, and the conversion took that much time, and the upload took that much time. So I can see what are the bottlenecks in my flow. And so that's what happens on the second monitoring statement. It's actually recording the execution time. There, it's a monitoring statement followed by the date, followed by the value, which is the execution time in seconds. So if you want to monitor Lambda, you should really be monitoring the function, but you should also monitor the triggers. So if you're dealing with S3 or Nessus or Dynamo, you should be monitoring those things as well. And then when your function's done, you're going to output it to somewhere. So monitor the output as well. And that will give you the full view of what's going on with all of your Lambdas. So as some examples, you might choose to do a stream processing pipeline. So each message that comes in gets a new Lambda invocation. You'll monitor the duration of each step, tag based on the data in each message and other types of metadata, and then eventually create some dashboards that look at that data in some really interesting and new ways. You could also have an image processing app. That's exactly the demo I showed. You have different size images uploaded, and you resize those images to standard sizes, maybe add some watermarks, add some compression, whatever you need to do for your environment, and then monitor the performance per size. Maybe add another tag that says image function size : small or medium or large. And that way I can start slicing and dicing, figuring out Okay, my smalls on this size memory take this amount of time, but on a super large one, it doesn't really take much less time. So maybe it's not worth giving it a lot of extra memory. You can start figuring out what is the sweet spot for the size of memory, the size of files, and so forth. So really neat stuff that you can do. Here's one dashboard, pretty simple dashboard looking at my Lambda functions. You can see the stack bar chart showing the different times. So you can see at where my cursor is in the lower left corner, I can see that the download time is really, really short, and processing and conversion took a little bit longer. So that's kind of neat. So in summary, AWS Lambda can be an interesting part of your infrastructure. It's very low cost to start. And serverless does not mean monitorless. Just because you don't have any servers doesn't mean you don't need to monitor. You still need to monitor even if you don't have servers. Again, my name is Matt Williams. I'm matt.williams or just mattw at datadoghq.com. You can reach me on Twitter as well, where I'm Technoevangelist. And the one URL I have at the bottom here is take a look at github.com/AWS Labs and then do a search for Lambda. You'll find a lot of great examples of Lambda functions and reference architectures for using Lambda. So again, thank you so much for listening. My name is Matt Williams, and look forward to hearing from you or seeing you at a future event very soon. Goodbye.